These folks have been lining up for days because word on the street is today Dr. Math is giving his properties of logs explanation, and these guys are just pumped. Back to you, Jim. All right, mathletes, so let's go ahead and let's look at the second half of these logarithmic properties, right? So I'm going to go through them and then I'm going to show you some examples of each one just so you know what to look out for and some traps not to fall for. All right, so let's dive in here and let's take a look. So the first rule we're going to look at is called the product rule, right? So what we see is you're going to have two factors here being multiplied. And remember, as long as two factors are being multiplied, we're going to be able to use this rule. And people might think, oh, here I have an 8 and an x, but you could have like a 8x plus 7 times the quantity of, say, 3x plus 5. So they don't just have to be monomials. You could be multiplying binomials, you could be multiplying trinomials, right? So again, as long as you're multiplying two factors, it doesn't matter what those factors look like. These rules apply. All right, so for this example, what they want us to do is to write the logarithm, right? One logarithm as a sum and then simplify it if possible. All right, so according to this rule, each one of these factors, right? Each one of these mother factors is gonna have their own logarithm. All right, so as I do this, I'm gonna separate this one, part A here, and I'm gonna have log of 8 plus log of x. And I wanted to make a mistake here on purpose because this is what we see all over the place. Is people, they separate each one of these factors and they give them their own log, but notice what our property says, that base has to remain the same because as you note, it's all about that base, oh baby. So this 2, don't forget that 2 has to tag along for the ride, right? So the base, this log has base 2, and this log has base 2. So again, that's a great note to add. All right, and then it says simplify if possible. So check this out. 2 raised to what power equals 8? Because remember, a logarithm represents an exponent. So 2 raised to what exponent? 2 raised to what power equals 8? And if you're listening to that guy behind you, right, number 1, what is he doing at your house? Number 2, he's correct. It is 3. All right. So here we can simplify that. This entire log becomes 3. The second one we cannot simplify, so it stays log base 2 of x. And if we want, we could put that x in parentheses, right? It means the same thing. So there's our final answer right there. Any questions? No? Good. All right. So let's take a look at this one, our natural log. So just because it's a natural log, that means it has base e, right? Log base e. The rules don't change. It's still, these properties still hold true. So in this case, let's highlight some things. I have 1, 2, oops, that's not a highlighter, that's an imposter. 2, and then we have 3, right? So we have 3 factors here. So what that's gonna tell us is we're gonna have 3 logarithms. So we're gonna have ln the natural log of 5 plus the natural log of x plus the natural log of y. Again, I didn't have to put that 5 in parentheses. I just want you to get comfortable with the notation here. And if you want to plug in the natural log of 5 in the calculator, get some decimal, that's okay, but I'm just gonna leave this answer the way it is, right? It's beautiful the way it is. All right, so if we're good, follow me to our next property. All right, so now we're gonna look at our quotient rule, the quotient rule. All right, so what this property really tells us, when you look close, it says make sure to hit that like button and subscribe. What are you waiting for, right? And then tell a friend or 10,000 of all the help Dr. Math is providing to you, right? A lot of people need our help. So again, do us a favor, spread the word. Alrighty, so log base b of m divided by n. So what this tells us is our numerator, right, is positive. So we're gonna again separate these logs, but this time the quotient is telling us that we have a subtraction. And what I like to think about is, remember, a log represents an exponent. So when I think about exponents, remember the rules for exponents. Say I have this and they have the same base, right? From looking at our rules of exponents, what did I do with those exponents? Well, I just subtracted them. So in reality, right, these have the same base, and I have this division here, and so what that's telling me is to subtract them, just like we did when we dealt with exponents. So they're very similar rules, right? So again, to help you memorize and understand logarithms. All right, so according to this, I have a log base 3, and I have a quotient here. So what this is going to say is I'm going to have log base 3 of my numerator, which is c, minus log, don't forget the base 3, right? You got to carry that base of d. All right, and in this case, I can't simplify any of those, so that's as far as that would go. So whenever your book or your instructor wants you to expand or to write these logs as multiple logs, as more than one logs, this is what you're doing. And what we're doing is just getting really comfortable with logs, because once we go into solving logs, then you're going to see that sometimes by expanding them, it's really going to help you out. It's going to make things so much easier. All right, so again, we want to get comfortable with all these properties. Let's look at part B here. All right, to be or not to be, here it goes. So here, using that same property, same principle, we have log of x minus log of 1000. And if you recall, right, anytime the base is not written, it's understood, right? It's understood to be 10. So there's an invisible 10 right here. Boom. So you're asking yourself, if I want to simplify this, 10 raised to what power gives me 1000? Well, 10 raised to the third power, right? And again, you can plug that into the calculator because it's base 10, and our calculator actually does base 10. So this whole thing is just 3, because again, 10 raised to the third power gives me 1000. Because what does the log represent? It represents an exponent. A log is an exponent. Remember that, you'll go places. All right, so next we're gonna jump into that power rule, right? It's all about that power. So the power rule. So notice this log, our argument here has an exponent. So what this rule says is that that exponent is gonna come to the front, boom. That p moves to the front. All right, so that's what happens here. So whenever I have an exponent, I could use this. The problem typically that I see here is people aren't very comfortable with their exponent rules or radicals, right? So let's help you out, right? Let's help you out. Step into my office. So whenever we have a radical, just as a reminder, that's going to be very helpful, right? You'll thank me later. Hopefully you'll thank me now by smashing that like button, but you'll thank me later, is that this exponent, right, whatever's on the inside goes on top, our numerator, and our index, right, this small number right here, this index is really small 5, goes in our denominator. So this is how you rewrite this using a rational exponent. Remember, rational just means a fraction. And so according to this rule, when you have this argument raised to some power, I could bring that fraction out to the front. And so this is the same thing as 2/5 times the natural log of x. And some people might write it like this. So again, there's so many different ways of writing it, they all mean the same thing. So again, just be very comfortable with notation, because a lot of people, they just get confused on notation and how to write things. All right, but if you're understanding this, all right, right on. If you have a question, just ask below. We got you, we're listening. All right, what happens when I have something like this? Well, this one's nice because it's just an exponent, so that 2, it's just gonna move to the front. Nothing big is happening. So I have 2 times log of x. That's as far as we could go, folks. So that's where we stop. All right, so there's times where we want to approximate, right? We're solving word problems, or we want to approximate these logarithms. And for the most part, most of our calculators, they don't allow us to change our base, right? And you have to be careful what type of logs arguments that you enter, because say you have a Dollar Tree calculator or a dollar store calculator, and then you punch in a negative number for the argument, right? That calculator might just blow up. So how do I punch this into the calculator? All right, so most calculators, they just have a log button. So let me tell you a secret. Come here. So how do I punch this into the calculator? According to this change of base formula, what I'm going to do is I'm going to rewrite this so that both of the bases that I'm going to use have base 10, because my calculator has base 10. And I could also rewrite it if I wanted to as both of them having the natural log, because a lot of calculators have the ln button, right? I was thinking of naming my son ln. Anyways, so what do? According to this property, this m, boom, we write it upstairs. So the argument goes upstairs, the base goes downstairs. So this 5 goes upstairs and this 2 goes downstairs, right? It doesn't matter which number is bigger or smaller. They always follow that pattern right there, right? So this could be ln of 5 over the ln of 2. And what's awesome is once you do that division, boom, it gives you the same answer. All right, so just in case you're wondering, how do I plug these into my calculator when the base is not 10? Now you know. Now you know. All right, so for our last example here, we're gonna go beast mode, and we're gonna look at a bunch of properties from this video and our last video, and we're gonna put everything together. So check this out. You have log base 5 of the cube root of 25 divided by the quantity a squared plus b squared. All right, so how do I expand that? How do I write this as multiple logarithms? All right, so first of all, let me use some algebra. So according to my algebraic properties, this is the same thing as having, let's put parentheses here, 25, that's a 25, let me erase that, 25 divided by a squared plus b squared. So that whole thing is now raised to the 1/3 power. Because when you take the cube root, that's the same thing as raising it to the 1/3 power. So what I might want to do is that 1/3, I might want to bring it to the front. What rule did I just use? The power rule, right? So that 1/3, I know I could bring it to the front. So let's do that. So more than anything, this is just a lot of writing, right? It's nothing crazy, it's nothing really difficult. It's just a lot of writing and making sure you're taking notes on everything that you're doing here. All right, and being very careful. All right, so we move that 1/3 to the front. All right, so now we have a division. So we have a division. One quantity upstairs, one quantity downstairs. So I'm gonna end up with 2 logs. But don't forget, each one of them is gonna need that 1/3, right? Because this 1/3 is attached to this entire thing. So if you want, you could say, you could leave the 1/3 on the outside, or right away you could attach them. But I'll just leave it on the outside so you could see. So if I expand that, I end up with the log base 5 of 25 minus log base 5 of the quantity a squared plus b squared. And just like I mentioned in the last video, these aren't going to separate into 2 logs. Only if this were a multiplication, that would happen, right? So again, make sure you really understand these properties. All right. Before I distribute the 1/3, let me kind of see if I can simplify anything. And right here, it looks like I could simplify this, right? 5 raised to what power gives me 25, or I could plug that into the calculator. So 5 squared gives me 25. So this whole thing right here is equal to 2. So let me write that down. This entire log is the same thing as 2. So we are left with, tell him Dr. Math, 1/3 times the quantity 2 minus the natural log of 5 a squared plus b squared. And again, no, we cannot separate that a squared and b squared into 2 logs. If they were being multiplied, we have a property for that. We don't have a property for addition and subtraction inside our argument, right? So now, last step, we're going to go ahead and multiply by 1/3. So let's finish that off. So we're left with 2/3 after we multiply that by 1/3 divided by log base 5 of a squared plus b squared all over 3. So again, let me write that 3 one more time for the West Coast. So again, all I did is I divided each one of those by 3 because it's the same thing as multiplying by 1/3. And there you have it, folks, right? So this ugly problem, it's not so bad when we take it step by step and we actually understand logs. So hopefully this was really helpful. Again, do us a big favor, smash that like button, subscribe, and tell some friends what we're doing for you. All right, mathletes, till next time, peace.